Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, here we go. We're going to start chapter 5 off. First couple of lessons for chapter 5 have to do with percents and finding percents. And so for this particular lesson, I'm going to introduce you to the percent proportion, and we're going to take a look at how we can use number lines to help us solve certain percent types of problems. So let's get started with the percent proportion. Basically, the percent proportion is a proportion used in percentage problems. And when we are solving percent problems, maybe you've already noticed that they are proportional in nature. In fact, when we were looking way back at the beginning of the school year, how you could convert a fraction to a percent, we literally set this problem up as a percent proportion. To find the equivalent fraction had a denominator of 100, and then once you knew what that fraction was with a denominator of 100, the numerator became your percent. So in this particular situation, 2 out of 5 is equivalent to 40 out of 100. Therefore, 2 out of 2/5 is equivalent to 40%. Okay, so we're going to use this kind of an idea in the context of problem solving. And what we will notice in almost all of our problems that we solve that involve figuring out a percent is that there's going to be a part and a total that's provided, and we have to figure out what the percent is after writing this as a ratio. But we'll also find out that you can be given the percent and a total and have to figure out the part, or be given the part and the percent and have to figure out the total. So what we do is these are the 3 basic types of situations where you will use a percent proportion to find a missing quantity. For instance, if it asks what is 20% of 50, you're going to notice that the percent part is always listed with the percent sign. So those two will go together here in our percent proportion. The total is always out of a certain number. So the total is always what, it's always given as like, it's out of this much. Well, that must be the total, right? So that quantity always goes down here in the percent proportion. And then the what is part always has to do with the part of the total, which goes right here. So they have to give you 2 of these 3 parts in order to solve these problems. If they don't give you 2, you're not going to be able to use these strategies to figure out the missing parts. Okay, so let's go ahead and take a look at this situation where it says, what is 20% of 50? Well, they've given us the percent, so we will write that above the 100 because 20% means 20 out of 100, right? And it's out of 50, so the 50 is going to be the total, which means we're going to try and solve for x. And now you can use proportional reasoning, and you can figure out, all right, 50 times 2 is 100, so 100 divided by 2 is going to be 50, and that's what we're going to do here. We're going to take 20 and divide it by 2 to give us x, which means x has to be equal to 10. Now, this will get a little bit more complicated. I've purposely chosen easy numbers that we can solve mentally so that we can get to our answers here relatively easily. But we'll see that we'll have decimal numbers and fractional numbers thrown in here, and we'll eventually use our calculators and probably cross multiplication to figure this information out. Okay, for the next one, it says 5 is 25% of what number? So we know the percent is 25, right? So I'm going to go ahead and put that there. And 5 is 25% of some number, and remember, the of always implies the total. So we don't know what the total is in this situation, but we know that 5 is a part of it and corresponds to the 25%. So those two are going to go in the numerator. And remember, the total corresponds to 100% always. So the totals always go on the bottom. It's always based on the total. So what would you multiply times 5 to give you 25? You would multiply times 5. So 25 divided by 5 gives you 5. So 100 divided by 5 means that x has to be equal to 20. So that means 5 is 25% of 20. And if you wanted to test it, let's go ahead and replace that with the number 20. And this times 5 is 100. 5 times 5 is 25. Yes, that verifies that that is the correct answer that we're looking for. And then in the last situation, let me go ahead and do this, and I'll do this one in what color should I choose? How about purple? Okay, so it says, what is 50%? So let's put our 50%, that goes above the 100, of 12. So in this case, we know the total is 12 because it's out of 12, and we have to solve for x. All right, this becomes a little bit more complicated. Think of, all right, 12 times what equals 100, but you know what I do notice? I notice we're talking about 50%, which is the same as 1/2. So if 50 is half of 100, then x has to be half of 12, which means that x is going to be equal to 6. So 6 is 50%, or half of 12 is the correct answer. So this is what I recommend you use as your go-to strategy for solving percent problems, right here. But we're going to spend the next 2 days exploring some CPM strategies for solving percent problems, which are also very beneficial and sort of helps you wrap your brain around what we're doing when we're solving percent problems. Okay? And in conjunction with these 2 lessons, 5.1.1 and 5.1.2, I have put a couple of resource pages from the online book into our Google Classroom that I highly recommend you take a look at, print off if you can. If you can't print them off, I would recommend that you at least look at them and copy down the information into your journal and use those as a resource to help you solve the problems that we're going to be working on today and tomorrow. All right, so food labels tell you about what is in the food that you eat. I'm sure many of you have seen these types of food labels on all the food that you get from the grocery store. Nutrition facts labels list the percentages of macronutrients such as protein, carbohydrates, fat, and so on, as well as vitamins and minerals in each serving. However, it often does not tell you exactly how much of each thing is in the food or how much you should have each day to be healthy. If you know how much vitamin C is in a serving, can you figure out how much is needed in a day? To help you answer a question like that, in this section, you will develop strategies for finding information about parts and wholes. Okay, so let's take a look and see what this question is asking us, and then we can go up here and we can do some highlighting of some information. It says the government has created guidelines for how much of various nutrients, vitamins, and minerals a person should eat or drink each day to be healthy. These guidelines are then used to create labels like the one shown above to inform the public about the nutritional contents of the food that you're eating. According to the sample above, 1 serving of Cheesy Mac macaroni and cheese contains 15% of the recommended daily amount of saturated fat that a person should eat. And just, to clarify, saturated fat is bad, okay? So you don't want to go over 100% of the recommended daily amount of saturated fat, or else it's not good for your heart. Whereas in other situations, vitamin C is good for you, other vitamins are good, so you'd want to make sure that you get that amount or more in your diet. But this one, it's like the maximum should be 100%. So when I'm looking up here, where's the saturated fat? Here's the information that they provide us. It says 3 grams of saturated fat represents 15%. And that is for 1 serving, which happens to be 1 cup. Okay, so in 1 cup of this Cheesy Mac and cheese, you get 3 grams of saturated fat, which represents 15% of the total you should have in any given day. So 1 serving of Cheesy Mac has 3 grams of saturated fat. How many grams of saturated fat should a person eat in each day? What would be the max that you should have in any given day? Okay, so what we want to do is to try and determine how many grams of saturated fat a person should eat each day. Look for more than one way to solve this problem. Okay, so moving on to the next page. I would like for you to copy down, in fact, let's go down to the bottom. Why don't you copy down this as your number line? Notice that I've got it partitioned, labeling 10%, 20%, 30%, 40%, all the way up to 100%. So please copy this down as I read through this problem. It says, to help you represent the situation in problem 5.1, copy the number line below on your paper. With your team or together with me, decide how to partition the line, that is dividing it into equal parts, so that 15% is shown. Okay, so before we go there, this is how I recommend students approach problems like this that involve percent. Okay, I would recommend that you think about the equivalent fractions that go with each of these equivalent percents. For instance, 50% is 1/2. So if I wanted to partition this in halves, the halfway point would represent 50%, right? And 1/4 is 25%. So you could put a 1/4 here and make that 25%, and you could put 3/4 here, and that would represent 75%. 20% is 1/5, 10% is 1/10, and 1/20 is the same as 5%. Now, the reason why I bring this up is because we're trying to figure out what 15% is. And 15% is not easy to partition on a number line. But 10% is pretty easy, and so is 5%. So if we put those together, we would figure out what 15% is, right? So it's based on this that I'm thinking it would be a good idea to divide this line into 20 equal partitions. And that's what I did down here. While I labeled every 10%, you can see that I've actually got 20 partitions because each 10% is cut in half. So this would be 5, this would be 15, this would be 25, and so on and so forth. Okay, so make sure that you partition this into 20 equal parts. That way, when we take 3 of those parts, that will represent the 15% that we are trying to find. Okay. So the amount of saturated fat in 1 serving of cheesy mac is 3 grams. Where would 3 grams be labeled on this number line? Okay, so keep in mind that we've got a situation where it said 15% is equal to 3 grams. So if 15% can be broken up into, say, 3 equal parts, each one of those parts would represent 5%, correct? So how many grams would you expect there to be in 5%? Well, 15 divided by 3 is 5, so 3 divided by 3 means every 5% is going to represent 1 gram. So when we come down to this number line, and this would be 5% right here. Let me actually make this kind of small. This part would be 5%. Each one of these sections is 5%, and this would be 15%. So this is, no, that is not correct. Every 5% is going to be 1. So I'm going to go ahead and label every single one of those 5% intervals as 1 gram. And how many total 5% intervals are there? There are a total of 20 of them. So how many total grams must be in this total serving? 100%. I shouldn't say total serving. I should say what total number of grams represents 100% of the daily allowance. So that's the number that we're going to put here. So let's come back up to problem B. Now that we've got this down, it says the amount of saturated fat in 1 serving is 3 grams. Where should 3 grams be labeled on the number line? Well, that should correspond to the 15% that is labeled on the number line. So 5% is 1 gram, 10% would be 2 grams, and 3% or 15% would be 3 grams. So now we're going to use this gram to decide how much saturated fat is the recommended daily serving. Okay, so let's go ahead and take a look and see some of the rationale that I used here. I'm looking at this, and I'm going to use some proportional reasoning here. If 3 grams is 15%, doesn't that mean that 6 grams would have to be 30%? Right? 1, 2, 3, 4, 5, 6 grams would be 30%. And 12 grams, when you double that, would have to be 60%. because 6 plus 6 is 20. And then you do that again, another 1, 2, 3, 4, 5, 6 would represent 90, right? If you take this and you triple it, you take that and triple it, and you would get 18 grams have to be 90% of the total daily recommended amount. So what would 20 grams be? How do we figure this out? Well, if you know that each one of those happens to represent 1, and this is 18, then the last two are going to make the total end up being 20 grams. Okay, so 20 grams is going to be equal to 100%. Now let's plug this into our percent proportion and see if we can get this to work the same way. Our part was, we knew 3 grams, but we didn't know the total. We knew that 3 grams was the same as 15%, so we'll write that as 15 out of 100. What do you multiply times 3 to give you 15? That would be times 5, correct? So this times 5 is 100, so 100 divided by 5, 100 divided by 5 is equal to 20, which means X has to be equal to 20 grams, which is the answer that we got here using the diagram. And here, using a little bit of logic, although getting those last couple pieces were a little bit confusing, but if I had just added, if 3 grams is 15%, then that means that 1 gram would have to be 5%, which means 10 grams, no, 2 grams would have to be 10%. And so when you add the 2 grams, which are 10%, with the 18 grams that are 20%, no, that are 90%, then the grand total ends up being 20 grams. 18 plus 2 is equal to 100%, which is 90 plus 10. So how many different ways did we approach this problem to make sure that all of our answers agree and we've got our brain wrapped around it completely? Like, there's a mental strategy, there's a percent proportion strategy, and there's a setting up a diagram strategy. All of them work, all of them are effective. All right, so one way to write the percentage, I already kind of showed this, is as a ratio with parts out of 100. So remember the percent proportion. Part out of the total is equal to percent out of 100. The part was the 3 grams. The total, we didn't know, and the percent was 15%. So once you set up the percent proportion, you can solve for X using proportional reasoning. So Jill represented the amount of saturated fat in the recommended daily amount with the ratio of 3 over 20. What does the 3 represent? Well, the 3 represents the part, right? And what does the 20 represent? The 20 represents, in this case, the total. The ratios 15 over 100 and 3 over 20 are different ways to compare the saturated fat in one serving to the recommended daily amount. How can you show that these are equivalent ratios? Well, we know that 3 over 20 is equivalent to 15 over 100 because when you multiply 3 times 5, you get 15, and 20 times 5 gives you 100. So just by using your giant 1, you prove that they're equivalent to each other. But you could also convert those numbers to decimals and to percents. 3 over 20 is equivalent to 15 over 100. We just proved it. If you simplify 15 over 100, it would simplify down to 3 over 20. If you change both of them to their decimal equivalents, it would be 1500ths, and to the percent equivalents, they would both equal 15%. So a few different ways that you could prove that these two ratios are in fact equivalent to each other, which proves that 20 is the correct answer that we're looking for. All right, let's move on to a different type of food. One granola bar contains 4 grams of dietary fiber. The label says 4 grams is equivalent to 16% of the daily recommended amount. Lewis decides to draw a diagram like the one below to understand this situation. So let's start by having you copy down this diagram, and I'm going to pause for just a second to let you do that. We'll work through each one of these questions below. Okay, so part A says copy this down and then add the label for 16%. So remember, 14 grams is equivalent to 16%. So this section right here, which is 14 grams, must also be the section that represents 16% of the daily recommended allowance. So how many grams of fiber are recommended each day? Well, how are we going to figure that out? How can we show this as equivalent ratios? Well, let's consider the percent proportion. We know that this represents part, and the total is this part over here, which is 100%. And we've been given the part and the percent. So to find the total, we're going to set up the percent proportion in this way. Okay, so think about proportional reasoning. Think of the giant one. 4 times something equals 16. What do you multiply times 4 to give you 16? Would be the number 4, right? So x times 4 is 100, which means 100 divided by 4 will tell you what x is. So what is 100 divided by 4? If you said it's 25, that is the correct answer. So that means that the total here has to be 25 grams. It says here how many grams are recommended each day? That would be 25 grams. How can you show this with equivalent ratios? Well, 4 over 25 would be equal to 16 over 100, right? So we solved for x to determine that that number, the total, had to be 25. And so we can show those two as equivalent ratios. Now, what percent fiber should Lewis get from other foods? Why is this percent equivalent to 21 over 25? So that's where we should finish out the rest of this. If we know the total is 25 and the amount of dietary fiber that is recommended from this one particular granola bar is 4 grams, the rest of it has to add up to 25, right? So 4 plus what equals 25? This quantity here has to be 21 because 4 plus 21 is 25. And since the percent represents the total of 100%, 16 plus something equals 100%. What is 100 minus 16? It is 84. So that completes this particular diagram. So why is this percent equivalent to 21 over 25? That's because 21 over 25 is equal to 84 over 100, right? Multiply 25 times 4 to give you 100, so 4 times 21 is 84, so the rest of it has to be 84%. What other amounts are missing? Well, there they are. The 21 grams and the 84% are missing. So now let's take a look at problem E. It says, Chris is eating cookies that contain 12 grams of dietary fiber, which he says is 48% of the recommended daily amount. How can you use ratios and B above, this part right up here, to check that 12 grams is equivalent to 48%? So basically what we're looking at here, we're trying to figure out if 12 grams is 48% of what number. So we're trying to find what the total would be. And what should the total be? It should be the same as here, right? Because we determined that there were 25 grams, which is recommended for the daily allowance. So is 12 over 25 going to eventually be equal to 48 over 100? Let's check. What do you multiply times 12 to give you 48? You would multiply 4, correct? So x times 4 is 100. 100 divided by 4, just like we said before, is equal to 25 grams. So we can see that 25 or 12 over 25 is going to be equivalent to 48 over 100. Now let's take a look at a different problem. One large carrot contains approximately 6 milligrams of vitamin C. The recommended daily intake of vitamin C is 60 milligrams. Risa wants to find out what percentage of her daily vitamin C she gets from one carrot. She started with a line divided into 10 equal parts. Now, why do you think she would divide this into 10 equal parts? Well, I'm looking at the numbers and I'm noticing, okay, 60 milligrams, if you divide it by 10, is equal to 6. So it makes sense that we would say that the total here is 60 milligrams. And the part is 6 milligrams. So that would represent right here, that would be the total, which is 100%, would be equal to 60 milligrams. So when you break that up into 10 equal parts, that means that 6 milligrams represents 10% of 60. So this part right here, which is one of the 10 intervals, is 10%, and that is 6 milligrams. So if each one of these is 6, And 10 times 6 gives you 60 milligrams. It's a horrible box there. Oops. I guess I'll put this back in, and we'll draw a much nicer box. Yes, I like that much better. So I think she divided that into 10 equal parts simply because 10 times 6 is 60, and 60 divided by 10 is 6. So that made it really easy to partition that 10 different ways. So it says copy the diagram and fill in all the missing. We didn't put this one in. If this is 10%, what does the rest of it have to be? The rest of it would have to be 90%, correct? And if this is 6, what do you add to 6 to give you 60? Or what is 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9 times 6. That would have to be 54. So the ratio of 6 milligrams over 60 milligrams represents the portion of vitamin C in 1 large carrot. Work with your team to find this ratio in the diagram. Do you see, actually, it's not too hard to see that right there in the diagram. Where do you see each amount? What other ratio could you write that would be equal to this? Okay, go ahead and take a look at the diagram and see if you can see another ratio that we could write in there that would be equal to this. What I thought of is this. If it's 6 out of the 60, then you could say, let's take a look at the percents. Actually, hold on for a second. I think I might have made a little mistake there. It wasn't the 6 milligrams out of the 10%. It was the 6 milligrams out of the total, right? That's what we have going on here, 6 out of 60. So if we decide to take the 10%, represents 1/10 of 100%, then that would be another kind of ratio that we could work with. So 6 over 60 is equivalent to 1 over 10 or 10 over 100. So finding a couple of other ratios in there, yeah, we could take 1 over 10. You could take 2 over 20. Of course, 6 over 60 is in there. 10 over 100, a few different ratios that you could work with there. Okay, so let's go back to our percent proportion and see if we can solve this one using the percent proportion. So if we're trying to figure out what percent we're working with here, the part is 6, the total is 60. It's the percent portion that we needed to figure out here. And so in this case, it might be actually best to reduce or simplify this fraction. But if you didn't, sometimes maybe we just do cross multiplication. 6 times 100 is going to be equal to 60 times x. And when you take 600 and divide it by 60, you get x is equal to 10. And since we're trying to find the percent, that means that 6 milligrams out of 60 milligrams represents 10% of the total. All right, and I believe this might be our last problem. Could it be? Could it be? Oh, I guess we've got, oh, here we go. This was the, this page was just, I guess you didn't have to copy those down if you downloaded the research page. Anyway, this is the last problem we're going to work on right here. Risa was mixing blue and red paint to create purple paint. She created the drawing below to show the portions of blue paint to red paint that she used. So notice that she's got 3 parts blue for every 12 parts of red. So looking at these parts, can you figure out what the total is? What statements can you make based on what you see here in this particular diagram? Go ahead and take a few seconds to think about that. All right, so what information do they give us? Well, they certainly give us this information, right? They tell us that 3 parts are blue. They also tell us that 12 parts are red. So if you know 3 parts are blue and 12 parts are red, how many total parts are we talking about? We're talking about 15 total parts in this particular paint. So there you go. Statements that you can make, you can say there are 3 parts that are blue, 12 parts are red, and 15 parts represents the total. So let's figure out what the percents are. How much of this paint is blue and how much is red. Let's set up the percent proportion for each one of these situations. We know 3 out of 15 is blue, so we have to use that to figure out what the percent is. And in this situation, you can do one of two things. You can either cross multiply, like I did, and get 15x is equal to 300, and then divide 300 by 15, or some students will do this. They'll say, hey, can't I reduce that to 1 over 5? And now that's friendly. 5 times 20 is 100, so what is 1 times 20? And it turns out the answer is 20. So that means that the blue represents 20% of the total. Now the red is 12 out of 15. So we're going to set up this as our proportion. And once again, you could simplify this down to 4 over 5 if you wanted to. And 5 times 20 is 100. So 4 times 20 is going to be the rest of it. Or you could do cross multiplication, which would end up giving you this as your equation. And then you would take 1,200 divided by 15. And that's going to give you 80. Now, another way of thinking about this logically is this. If you know this represents 20%, from here to here, let me actually put this down here. Stop it. Can't believe I would do something like that. Boom, boom, boom. Okay, if you know that this is 20%, then you know that the rest of it has to be 80%, right? Just using a little bit of logic there. But it's nice to prove it using your proportional reasoning here. Even if you didn't simplify those, you can do your cross multiplication and use your calculator to help you along the way. So I'm going to tell you right now, your calculators and this percent proportion are your best friends for solving these types of percent problems. Because once you get everything set up, the part over the total equals percent over 100, and you cross multiply, and you divide, it doesn't matter how ridiculous these numbers are. They can be fractions, they can be positives, negatives, they can be decimal numbers, but you're going to just use your calculator, multiply them together, then divide. Whatever the calculator tells you X is, that's your answer. And in this particular situation, since we are trying to find percent, we would just label these as percents. In the other cases, you would label them as grams, right? Because that's what we were talking about. Oh no, I guess in this case they were parts. So there you go. A little bit longer video today. There was a lot going on. There's going to be a bit going on in tomorrow's lesson as well, because these are big ideas for 7th grade math. We use this kind of math all the time in real life. Probably no other type of math is used in your adult life than what we're doing right now with 7th grade math. So just practice it. The more times you do it, the easier it'll become. Use your calculators along the way. And this chapter 5, we are going to eventually get to problem solving and using successful strategies along with proportional reasoning to solve pretty much any type of problem that you're going to run by in everyday life. Okay, so I'm going to stop rambling. Let's go ahead and move on to, I guess we're probably going to have a check for understanding for this lesson, or maybe I'll do it. Maybe I'll do it after tomorrow's lesson. We won't have one for today. All right, take care. Bye.
Hey, feeling good, like I should.